Hey guys, today we'll start with some new things on Python, such as operators. What do you mean by operators in Python? Now, operators in Python are special symbols. Okay, you can call them symbols or sometimes keywords. Yeah, that are used to perform certain most commonly required operations. Yeah. Uh, Operations on value, variables, or expressions. Yeah. And this could be one or multiple. Yeah. So there are special symbols that we use to perform our operations. Now, these are various types of operations. When I'm talking about operation, there are various types of operators. Yes. Uh, One is arithmetic operators. Yeah. I'll just keep it arithmetic. Uh, right. Arithmetic. Okay. Yeah. Second could be is the comparison operator. Next is the assignment operator. Then we have logical operators. Then we have bitwise operators. Um, we have membership operators. We'll see all these operators one by one in more detail. Yeah, as we go ahead, deep dive into uh, looking what it is. And the last is the identity operator. Yeah. Now, arithmetic operator is nothing but it used to perform basic mathematical operations such as addition, subtraction, multiplication, etc. Yeah. Comparison operator. Now, this operator compares the values on either side of them and decide the relation among them. So they are called relational operators as well sometimes. Yeah. Assignment operators are used to assign values to a variable. So as we have seen earlier, like a equals to 10. So equals to is what you mean by assigning. So that is our assignment. So there are various types of assignment operators which you will see. Next one which I have written is the bitwise operator. Now, bitwise operator works on bits and performs bit by bit operation. Now, bit by bit operation in the sense it will convert the value into bits like zeros and ones, yeah, and then then perform operations on them. Yeah, we'll see those as well. Next are logical operators. These are are now used to combine two or more conditions and check the final result. So there are, suppose I have two conditions to check if there are to arrive at a result, then I will check for the logical operators like and or not. Yeah. Then we have membership operators. Now, membership operators test for membership in a sequence, such as string, list, or tuples. Yeah, there are two membership operators, in and not in. We'll see this as well. Yeah. And last is the identity operator. Now, identity operators compare the memory locations of two objects. So that is why it is called identity. So it checks for the identity of that object. Yeah. And lastly, after finishing all this, we'll see how operators are preceded by each other. So we'll see operators precedence. Yes. Yeah. Sounds good. So let's start with our basic operator, that is arithmetic operator. Yeah. So we have arithmetic operator. Yeah. Now, what is arithmetic operator in Python? Yeah. Uh, this is nothing but uh, Python using symbols. Now, we usually use numbers in Python. Yeah. So we frequently use the int data type in Python. Now, Python uses some symbol for basic arithmetic. Like you must be have seen the addition symbol. Yeah, for subtraction there is a minus symbol or the hyphen symbol. You have the star for multiplication. Yeah. So this way there are various symbols which Python uses to perform operations on numbers. Yeah. Now the arithmetic operators are binary operators in the sense they operate on two operands. Yeah. So you need to always remember that these operators are binary operators in the sense they operate, okay, are binary operators in the sense they operate on two operands, that is value. Yeah. Now Python fully supports mixed arithmetic. Now that is the two operands can be two different number types. Yeah, it could be float or an int. Yeah. In such a situation, Python widens the narrower of the operands, and integer object is narrower than float object, and float is narrower than a complex operation. Hence, the result of the arithmetic operation of int and a float is always a float. Yeah. And if I the result of float and complex is a complex. Similarly, operations of an integer and a complex object results in a complex object. So you need to always remember this when you're using arithmetic operators to perform certain tasks. Yes. Now, what are the different types of different types of arithmetic operators? Yes. Now, the first one is addition. So this symbol is used for addition. Yes. This symbol, I don't know whether you're able to see this. Okay. I'm going to put it in quotes. Let me see if it takes that. Okay. This is addition. Yeah. This is subtraction. This is subtraction symbol. Uh, this symbol is okay. It is not showing the symbol. I have to put them in double quotes to show that. So this is multiplication. Yeah. So the star symbol is a multiplication symbol. Forward slash is a division symbol. You have a percentage symbol, which is modulus. Then we have double star, which is exponent. We'll see the operations of all the symbols one by one. Then we have double forward slash, which is used for floor division. We'll see what is the difference between normal division and floor division by examples. Yeah. So these are various types of symbols that we have seen. Yeah. Theoretically. Yeah. Now let's start one by one. Let us study this one by one. Yeah. So first we'll study on the addition operator. Yeah. Operator. Yes. Now suppose now this operator pronounced as plus, or you can say plus. Yeah. Is a basic arithmetic. It adds two number. That's it. Yeah. So what it does is it adds two numeric operands. Yeah. On the either side of the symbol. Yeah. So let's do some coding. So A, suppose I have A equals to 10 and B equals to 20. Yeah. Now if I want to print addition of two integers. Yes. I'll say print A equals to, just do some formatting. I'll say is equal to A, B equals to, yeah, I'll say B, and the addition of the two numbers would be addition equals to, comma, which is A plus or addition B. Yes. To simply add two numbers. Let's see what is the output. We should get 30 as the output, which is A plus B, which is 10 plus 20. Yeah, you can see this. So you have A as 10, B as 20, and the addition as 30. So now let's try to uh, add an integer and a float. Yeah. Let's try to make it a bit complicated. This was, let's see, addition of two integers. Yeah. Now we'll do addition of integer and float. Yeah. So suppose I make this to 22.35. Yeah, I keep this as integer. I make this B as float. So addition of integer and float. Yeah. So A equals to B. Again, addition A plus B. So it should generate a float. As we said earlier, when you add, when you have the in arithmetic operator, when you have int and float in the operation, the float takes precedence. Yeah. So the output would be a float. So let's see how it takes place. You can see this. It has the output is 32.35. So float has taken a precedence over it. Yeah. Let's see if we put a complex and a float. Yeah. So it should take complex number should take a precedence. Yeah. So this time we are doing complex and a float. So that's right. Complex and a float. Let me change A to 10 plus 3j, anything. Yeah. This is a complex number. We know this, yeah, which we have seen earlier. And this is a float. Yeah. So addition of a complex and float, what is the output? It should give us a complex number. Let's see. A plus B, 10 plus 5j, 3j. We have done it right. We have taken a float. 10. Okay, we have not run this, so we need to run this. Yeah, you can see this 32.35 plus 3j. Yes. So this is how the addition operator works. Yeah. So this was addition operator. Let me write it in capital so that we can bifurcate it as we go ahead. Addition operator. Yeah. Same way, we have a subtraction operator. Subtraction. Dash. Subtraction operator. This is again denoted by a minus symbol, yeah, which you have seen earlier, the kind of symbol that we have seen in the text, and it usually subtracts the second operand from the first. So it subtracts the second operand from the first. Yeah. So this is how this operator works. So let's see some example. Let's see some example by this. So suppose we'll take the same thing which we have done earlier, 10 and 20. Yeah. I need to always remember that the subtraction, if the second number is higher than the first number, yeah, then the result would be a negative number. So let's see one example for this. So A is 10, B is 20. Yeah. Let me make the first number higher. Yeah, 50, and B is 20. Yeah. So I'll say subtraction of two integers. So I'll say A minus B. So this time A is higher than B. So it should be a positive integer. Yeah. See this? So the difference, okay, not addition, this is subtraction. A minus B is 30. So 50 minus 20 is 30. Now, if I try to do it the other way, if I try to subtract A from B, so B minus A, since B is smaller than A, it should give me a negative number. So you see this minus 30. Since A, yes, A is bigger than B, if we try to subtract A from B, then it will come to be a negative number. Yeah. Now let's try to do the same with float. Yeah, we'll use the same thing. We'll change one of the number to float. So suppose I change B to again 23.75, any odd number. Yeah, subtraction of integer and float. Yeah, let's see what is the result. It should give us float as we have seen earlier. Yeah, 26.25 or 26.25, negative or positive, whatever it may be. Yeah. Same way, If I try to uh, do it for complex and float, we'll use the same example. Do it for complex. Let me make this a complex number as 5j. Yeah, subtraction of complex and float. Yeah. So a minus b, I'll keep it that way. Let me run this. So we have a as complex. So you get a complex number again. Yeah. So this is how subtraction works. Yeah. Now let's see our next operator in arithmetic operation is multiplication. Multiplication. Yeah. Operator. Now this is often denoted by asterisks. Yeah. Now this symbol is defined as multiplication operator. Now it returns the product of two operands. So what it returns? It returns the product of two operands. Yes. Now you need to be sensible enough that if any operand is negative, the result is also negative. But if both the operands are negative, then the result is a positive. Changing the order of the operand doesn't change the result. Yeah. So let's see it with an example. So let me take the same example as we have taken for addition. Sorry. I'm going to take the same a equals to 20. So I am doing a multiplication of two integers. Yeah. So equals to 2. This is into. So I have used an asterisk to multiply, and I have to write as multiplication. Yes. So I say multiplication of two integers. Yes. Multiplication of two numbers. So it should either give us 10 into 20, that is 200. Yeah, A into B. Well, now let's try to do an integer into float. Yeah. How we can do that is let's have multiplication of integer and float. Yes. So suppose I make 20 as 20.80 or 20.5. This is a float number. Let's see what is the output. It should give you a float as an output. See this? You have 205.0 as the output. Yeah. Let me make it 15. So you get a better output with some number in the decimal. Yeah. So 0.5. So it gives you a float. So if I try to multiply float by float, so if I have 15.55 and I have something like 6.75 exponential minus 3. Yeah, something like that. So if I have multiplication of float and float, yeah, let's see what happens. So this. Now the multiplication of float operand may have standard decimal point notation or a scientific notation. So here above we have seen with a standard decimal notation, and this is a scientific notation of a decimal or a float number. Yeah. Now let's try to do something like having a complex number. So we'll use the same a float, a complex and a float number. So I have a complex and float number. So let me make a complex number. So this is a float number. So again, I use the same thing, 10 plus 3j. Let's see what is the output. Yeah, you can see there is a complex number which is created as an output. Yeah, you can see this. J is the imaginary number plus you have this real number, and the J is the imaginary number which is a complex output. Now in multiplication, we have seen that if you multiply negative and a positive number, it gives you a negative number. Let's try that as well. So let's keep it simple. Yeah. So we have seen a positive and positive, which gives you a positive number, which positive means there is a no negative symbol. So let's make 20 as negative number. So adding a subtraction sign. Yeah. So this is a negative integer stored in B. So let's see what is the output. It is minus 200. Now in spite of 20, let's make 10 as a negative number. Either way, anyways. So putting 10 as the negative number and keeping 20 as a positive number. So it should again give you a negative number. So either of the operand, if they are negative, the result would be a negative. But if both the operand are negative, then the result would be a positive number. See this? It is positive 200. So you need to be very careful when you are writing this sign so that you get the perfect result. Yes. So these are the various ways in which you can use multiplication operator. Now let's move ahead to a next operator, that is division. Yeah. Now division is mostly shown by a forward slash. Yeah, with the symbol we have shown earlier. Now the result of a division operator is numerator divided by denominator. So that is left divided by right operand. Yeah. So it is numerator which is left operand divided by denominator which is right operand. Yeah. The resultant number is negative if any of the operand is negative. Since infinity cannot be stored in memory, Python raises a zero division error. We'll see this. Yeah. Let's try to divide. Let's have this two numbers once again, which we used earlier. But we use this. Use this. Yeah. Example. I'll say division of two integers. I say A divided by B, and I'll say B divided by A. Let's see what happens. Yeah. Yes, sounds good. So A is 50, B is 20. I am doing a division of two integers. Yes. I am first dividing a by b and then dividing b by a. Both will give me a different result. Let's see this. So this, if I divide 50 by 20, it gives me 2.5. But if I divide 20 by 50, it gives me 0.4. Yeah. So the output of a division will always be a float. Even though both are integers, you have seen this. Even if both are integers, the output will always be a float, which is 2.5 or 0.5, something like that. Yeah. So let's try to divide now. Let's try to divide integer and a float. Yeah. So suppose I have 20.5. Yeah. So you have one integer and one float. So integer and float. Yes. Let's have the same thing, a divided by b. Sometimes we are dividing float by an integer or integer by a float. We'll see both operators, what happens exactly. Yeah. See this? You have different result, but all are in float only. Yeah. So either you divide by two integers or you divide integer by a float, you'll still get a float. Yeah. Let's try to do it with two floats. Yeah. Suppose I have b as 20.5 and we have this as a scientific notation of, yeah, we have a scientific float notation and we have a normal numeric float notation. So it's a division of float and float. Yeah. Let's see what is the result. It should again come to a float. Yes. Now let's try to have a complex number. Yeah. So if I try to divide a complex number, I try to make this a as a complex number, make it 13 plus 5j. Okay, so I made this a complex number. So 13 is a real number, 5j is an imaginary number, 20.5 is a numeric float. Yeah. So you are division of complex number and a float. Let's see. It will always result in a complex output. Yeah. Yeah. Because both part will automatically turn into complex as per the theory which we have seen earlier. Now, if the number or the numerator is 0, it should return you a zero division error. Yes. So let's try to do that as well. We'll get of 0 and integer. Any number. It could be integer or a float. You can use anything. Yeah. So currently I'm dividing 0 by 20. Yes. It should give me an error. Yeah. It is a non-digit. It turns into infinity because 0 cannot be divided by 20. Yeah. This is 0. This is 5. You have a equals to 0, b equals to 2.5, and I'm dividing a divided by b. Should come up with an error. Division of 0. I'm doing something wrong. Okay, b, you cannot divide by b. Okay, you cannot divide by 0. I'm very sorry. That's why I'm dividing by 20, which would result give me a 0. But by dividing 20 or any integer of float by a 0, it will give me an error. See this. Yeah. So the first one is giving me a result, which is a 0. Because if we divide 0 by any number, it will always come out with 0. But if we try to divide any number with a 0, then it will come up with a 0 division error, which is the way it is infinity. So you cannot divide anything by 0. Yes. Let's now move to our next operator in arithmetic operators, which is modulus operator. Yeah, modulus operator. Now it is denoted by a percent sign. Yes, this is denoted by a percent sign. Yeah. Now you need to understand is it returns the remainder after the denominator divides the numerator. Yeah. Okay. If someone has done mathematics where you divide a particular number and if there is something which is remaining, that is called a remainder. Yeah, it returns that remainder. Yeah, the result of the modulus operator is the number that remains after the integer quotient. To give an example, when 10 is divided by 3, yeah, the quotient is 3 and the remainder is 1. Because if you say 3 into 3 is 9. Now, if I subtract 9 from 10, the remainder is 1. Yeah. So the result of the modulus operator is 1. Yeah. So let's see how it happens in various scenario. We'll try to do it by various ways as we did earlier. So usually it returns the remainder after the denominator divides the numerator. Yeah, sounds good. Let's see some example. So if I'll use this same example to put it here. So suppose I have A as 10, yeah, and B as 2, yeah, and I have modulus of two integers. Yes, so modulus sign is percentage. So you have A value, you have B value, A is 10, and I have to put the percentage sign to get a answer. Let's see, it should give 0 because nothing would be left after dividing 10 by 2. So 2 into 5 is 10. If I subtract 10 from 10, it would be 0. So that's why this answer. Yeah. Let's try with some other example. Let me divide it by, instead of 2, I divide it by 4. Yeah. The answer should be 2. Yeah. Let's see what happens. See this? Because 4 into 2 is 8. 4 into 3 is 12. So 12 is greater than 10. We cannot subtract it. So 4, we take 4 into 2 is 8. If I subtract 8 from 10, the remainder is 2. Yeah. Let's use the same thing by dividing B, having B divided by A. Let's try something else. So I am trying to divide 4 by 10. If I do it the other way around, I put here B and then here A. You find the output as 4. Yeah, it's not division. Let me correct all this formulas here. So this is modulus. Again, this is modulus. This is modulus. Let me rerun this formulas to give you the right picture. B divided by A. Yes. Let's put a twist as we did for multiplication here, division here. Yeah. Let's do the same with modulus operator. So if I do the same with modulus operator, 0 divided by, I keep it a bit simple. Yeah. By keeping integers 0 and an integer division, not division, it is modulus of 0 and integer. So again, here modulus. Okay. What we are doing is, here we have two variables, 0 and 10. I am trying to find the modulus of A modulus B and B modulus A. Yes, let's see what are the results for both. See this? If I try to find the modulus A to B, then it gives me 0, it should be an normal way. But it gives a 0 division error if I try to do the modular of by 0, which is an infinity, which we cannot divide a particular number by 0. Yes. Let's try it by a float. Yeah. In various ways by having various ways by having, let me put it in various formats first. So if I have A as 10 and B as 2.5, which is modulus of integer and float. Yes. Let's see what is the reason. Usually it should get 0. Needs to be, which is 0. 2.5 would be modulus of, okay, I have done it the other way. So it's to be A is to B. We'll try it the other way as well. Don't worry. Yeah. Let me change a bit more. I make it 1.5. So 10, I'll make it 1.5 so that we get some decimals as well. No, 1.5 will not fetch you the decimal. What I can have two floats. Let's see. I had one integer and a float. Let's see if I have a 7.7, any number, modulus of float and a float. Let's see what happens. So it gives me a decimal number, a floating number. Let's see what happens if I have float in the numerator, yeah, and I have an integer in the denominator. Let's see what happens. Okay, it gives me a float. Yeah. So the mod value of an integer and a float will always be a float. Yeah. Python doesn't accept complex number to be used as operand in modular. So you will not be allowed to use complex error. It throws a type error. So let me see if I try to put a complex 3 plus 5 way. So this is a complex number. Yeah, I'll add float and complex. So it should give you an error. Yeah, yeah. This is a type error. You cannot use in modulus a complex number. Yeah. So this is how modulus works. We have seen a lot of examples in this. Yeah. In modulus, we have seen how the errors also occurs. Now let's move on to our next operator in arithmetic operator, that is exponent operator. Yeah. This is usually defined by double double asterisk. Yes. Now, when you're saying double asterisk, this is usually spelled as exponent operator or raise to operator. You can say exponent operator or raise to operator. Yeah. So if I have a exponent of b, you say a raised to b or even bth power of a. Yeah. So you write the symbol as a raised to b. Yeah. If in the exponential expression both operands are integer, result is always an integer. Remember that. Yeah. So if in case either one is a float, the result is a float. Similarly, either one is a complex, the number exponent operator returns a complex number. If the base is 0, the result is 0. If the index is 0, then the result is always 1. So let's try one by one each operator. So let's try with the integer first. So as we did earlier, so if you have both as integer, yeah, we put it both as integer, exponent, yeah, of two integers. So a, yeah, raised to b, which is a, suppose I'll make it a bit simple, 3 raised to 2, which is 3 2 times, or raised to 4, 3 times. Let me make it simple, 3 raised to 2, which would be 3 into 3 2 times, which is should be the answer should be 9. So exponent, sorry, a raised to b. Yeah, you see this? So the number of times 3 would be multiplied will depend on the exponent function or the exponent number, which is raised to number. So here the second part is the raised to number. So 3 raised to 2. So 3 is multiplied 2 times. Then if I said 3 times, then it would be 27. So 3 multiplied by 3 multiplied by 3. Yeah. So 3 into 3 is 9. 9 into 3 is 27. So this is how it happens. Yeah. So integer into integer, it gives me an integer. If I try to have a float, I'll say 1.5, it will give me a integer and float. It will give me a floating number. You see this with a decimal. Yes. Let me add some few lines to get more codes. Yes. Next is even if I have the other way around where 3.5 is and I have it as integer as the exponent raised to function, still it will return me a float. See this 12.25. Yeah. Now suppose one of the number is a complex number. So if you have one of the number as complex number, complex and an integer. Yeah. To make it 3 plus 5j, I make it a complex number. Yeah. So the result should be a complex number. You see the result? So if I have an integer in an exponent function and one integer or a float, but if one of the either is a complex number, then the result would be a complex number. Yes. Now let's try the last one as we discussed. If the base is 0, the result is 0. If the index is 0, then the result is 1. So if the base is 0, so suppose I keep a as 0, which is the base. Yeah. base 0 or index 0. Yeah. Let's see what happens. So if I try both ways. So I make first I'm making the base as 0, which is the left hand side. And in the second, I'm making the index as 0. So A is the index here, A is the base here in the first formula. So let's see what is written by both the formulas, where A is the index, A is the base, yeah, and it is 0, then it should return a 0, yes. Where A is index and it's a 0, then it should return a 1. So you should remember this. Yeah. So this is how the exponent function or the exponential function or the operator works. Yes. This pretty clear, I guess. Yeah. Now let's move on to our next operator, which is a floor division. Yeah. Now floor division is identified by a double forward slash. Yeah, let's write this floor division operator, which is double forward slash. Yeah. Unlike the modulus or modulo operator, yeah, which returns the remainder, the floor division gives the quotient of the division. If both operators are positive, floor operator returns a number with fractional part removed from it. For example, the floor division is 9.8 by 2 returns 4. Pure division is 4.9. Strip the fraction part, result is 4. Yeah. So let's see some example to understand. It's a bit complicated, but you also need to know if one operator is negative. Yeah. If one operator is negative, the result is rounded away from 0. Floor division of 9.8 to 5 pure returns 5. Pure division is minus 4.9 rounded away from 0. Yeah. So let's see some examples. So we'll take some of the above where both are integers. Yeah. What it gives you is it's yeah. So where floor division floor division, I am dividing two integers. Yeah. Let's see what it gives me. Suppose I divide 9 by 2. What happens? It gives me 4. Yeah. So 2 fours are 8. Yeah. And the remainder would be 1, which would be, if I have written a modulus operator, it should have given me 1. But it gives me something which I have divided it by. Yeah. So the modulus of 9 by 2 is 4. Let me try it with the negative value. So I have two integers, but one of them is negative. Yes. So let me keep 2 as minus 2. Yeah. So I have this operator. Hmm. Let's see what is the result. Yeah. You see this? The floor division is minus 5. Yeah. Let's make one of them to a float number. So the result would be integer and float. So I make it 2.5. Let's see. The answer is 3.0, which is in a float format. Let me make it a bit more complicated by making 9 negative. So if I have the 9 as a negative number, which is minus, and I have a float as well. So you have a negative integer and a float. Let's see what is the result of that. So it gives me a negative float. Yeah. So these are some of the examples. Yeah, you can play around with all these operators to get more understanding of how it happens. Yes. Now there are few things that you need to understand. Yeah. There are some precedents when you're talking about operators, arithmetic operators. Yeah. So the precedence would be like uh, the exponent operator. Yeah. This, oh, sorry, let me write it properly. Exponent operator. Yeah. The associativity of this operator is right to left. Yes. So it is the index that has a precedence. Yes. Whereas in percentage, uh, multiplication, division, division, or floor division. Yes. In any of this, the associativity of operators is from left to right. Yeah. Again, even addition and subtraction also is from left to right. Sounds good? So this is the precedence and association of Python arithmetic operators between the operands that they mix up with. Yeah. Now there is another thing that we can get into, which is complex number arithmetic. Like arithmetic operators behave slightly differently when the both operands are complex numbers. Yeah. Now addition, subtraction of complex number is a simple addition or subtraction of respective real and imaginary component. So 2.5 will become plus minus 3 would become 0.5, or addition would give 5.5. Yeah. So let's try something different, which probably no one has taught you before, which is complex number arithmetic. Yeah. Okay, write it. Yeah. Now, if I have two, now, as I said, arithmetic operator behaves slightly. slightly differently when you are doing any operations on complex numbers. So if I have a complex number a equals to 2 plus 3j, and I have another number which will be equals to 5 plus 9j. Yeah. Now if I try to add these two numbers, yeah. So if I have addition of these two numbers, let me run this. I'll keep this in. Let's have addition of these two numbers. Yes, a plus b. Let's see what is the result. So it gives me 7 plus 12j, which is straight addition of these two. Yeah. Now let's try to subtract. I'll do it the other way around. Like b is the bigger number. I'll say a minus b, which is subtraction. Let's do it both ways, like a minus b and do it with b minus a. Let's do it other way around. Let's see what happens and what is the output that we get. See the output? So a minus b is giving me minus 3 minus 6. Yes. So 2 minus 5, it is minus 3. 3 minus 9 is minus 6. If you do other way around, 5 minus 2 is 3. 9 minus 3 is 6, which is 3 plus 6j. A straightway addition and subtraction. Now multiplication of complex numbers. Now this is where the interesting thing comes in picture, where multiplication of a complex number is similar to multiplication of two binomials in algebra. Yeah, yeah. So two complex numbers, then the multiplication is given by the formula. You can, if that is a plus bj, you need to understand this. So this is how it happens. The multiplication will result in this arithmetic. So what it is if I have the formula a plus 3j and x plus yj, yeah, then it would be a into x, which is a, which is the real number, into this real number. And then you have a, y, j. Yes. So you have a. So a gets multiplied by x, the real number. Then a gets multiplied by yj, which is the imaginary number. Then bj is the imaginary number, yeah, which is getting multiplied. Yes. B. Okay. B and y. Sorry. The imaginary number b and y gets multiplied, j. And lastly, the last one, b, y, j2. So b and y and j2. Yes. So this is how it's not bj, it should be bx. I'm very sorry. bjx. Okay. bx, bj. This is perfect. X into bj. And then you have bj, by j2. Perfect. Yeah. So this is how it takes place when you are doing a multiplication. Yeah. Let's try to do the multiplication as well of this two numbers. I use the same formula. I'll use multiplication. This is just for your information. You do not need to worry about it. What's happening? This is just for your information so that you understand what is the logic behind behind the various operators that are being operated on simple formulas or multiple floats, integers or complex number. How does it get reacted to it? And how does the multiplications or the divisions takes place on various kind of operators. Yeah. So this is what we have got for a multiplication. Now, to understand how the division of two complex numbers takes place, we should use the conjugate of a complex number. Yeah. The Python's complex object has a conjugate method that returns a complex number with the sign of imaginary part reversed. So if I have a equal to 2 plus 3j and I say a dot conjugate, yes, it will give me 2 minus 3j. See this? Now to divide two complex numbers, divide and multiply the numerator as well as the denominator with the conjugate of the denominator. Yes. So how do you do that? So you put the division directly and you'll get the result. So division A divided by B and you'll get the results. Yeah. So you need to divide two complex number, divide and multiply the numerator. Yes. Let me write it once again. So you divide two complex number, divide and multiply the numerator as well as the denominator with the conjugate of denominator. This is how we get this kind of result for, yeah. Now the complex class in Python doesn't support modulus operator or floor division. Always remember this. So complex class or complex numbers do not support modulus or division. So this is a very comprehensive arithmetic operators that we have gone through. Hope you have liked this session. Yeah. And you'll use these various methods that I've used to learn more about addition or subtraction, division, or the various operators which are then there in arithmetic operations. Yes. Thank you so much.